팽하, 팽하. When you say good morning, you say 팽하. 팽하, nice to meet you.
It seems you're referring to a phrase or cultural reference. If penghang is meant as a unique way of greeting, or if it has a special significance in a particular context, let me know more details. If it's a playful term or reference you'd like to incorporate into professional or informal English greetings, I can help you phrase it smoothly.
Apologies for my bad pronunciation. 펭수 is very unique and very unique entertainment character in Korea. He's very famous, and when he say goodbye, he say 팽하. So let's say 팽하, 팽하.
Oh, I see. No worries about the pronunciation. I got it now. Pengsu sounds like a fun character, especially with his unique way of saying goodbye. So let's give it a try together. Penha? Penha?
팽하 means hi or good morning.
Got it. So Pana is Pengsu's way of saying hi or good morning. That's such a fun greeting. All right, Pana.
Okay, 팽하. First of all, I want to make it clear that I'm just a student, not a teacher. This YouTube channel is not about teaching English to someone else. This is just to show my own process of English speaking practice. That's the purpose of this channel. I just want to show that even elderly person like me, who don't use English regularly in daily life, can learn to speak English. Listen carefully. I have something to tell you. We don't have time. When I used to practice the speaking practice session like this, a few months ago, nearly 7 or 9 months ago, even on 30 minutes, even an hour felt very long. However, as I've gotten used to this, even 1 hour and plus 30 minutes practice session feels short, very short. I feel like this time is very short to me these days. I have so much to say within the given time. So let's hurry and get started.
Here's a more natural version of what you shared. First, I want to make it clear that I'm just a student, not a teacher. This YouTube channel isn't about teaching English to others. It's simply to show my own English speaking practice journey. The purpose of this channel is to demonstrate that even older learners like myself, who don't use English daily, can still learn to speak it. I'd like to share something with you. Time feels limited. When I first started practicing English about 7 or 9 months ago, even a 30-minute or 1 hour session felt long. But now that I'm used to it, even a 90-minute practice session feels too short. These days, I have so much I want to say in the time I have, so let's get started. This version sounds smooth and clear, but you've already expressed yourself really well. Just a few tweaks help it sound even more natural for a YouTube audience.
Okay, okay, I got it. Well noted. I got it. I really appreciate your kind support. Well noted. And I'm honestly speaking, I'm inspiring. Okay, I got it. Okay, I think we already exchanged our greetings. Let's move on to the next part. I would like to I like to do dialogue practice time with you. Did you get a chance to review my six dialogue file? I mean text file, six text file. Let me see. What version, which file is best for today? Let me see. How about number four? workplace compensation examples for manufacturing. Can you recognize, can you access the file?
All right, I understand. Thanks for letting me know. I'm ready to dive into some dialogue practice with you. Yes, I reviewed the files and I see the manufacturing dialogue examples in file number 4. It has detailed conversations on the manufacturing process flow and specific dialogues around steps like SMT, surface mount technology, and assembly line tasks. So, I'm all set to practice that with you. Let's start with a specific scenario from the file, or if you have a particular section in mind, let me know and we'll jump into it.
Listen carefully. First of all, I would like to introduce the number four compensate workplace compensations examples for manufacturing. I would like to share with you introduction of this file. Listen carefully. Here's a detailed and simple explanation of the manufacturing process flow for the SMT line and assembly line based on the provided process flow. This is intended for this is intended for a new exam. This is this is intended for a new employee at Ford company. So I will keep it. So I will keep it clear and straightforward.
Got it. Here's a refined introduction for presenting the workplace conversations examples for manufacturing. First, I'd like to introduce workplace conversations examples for manufacturing, specifically focused on the SMT line and assembly line processes. This file provides a clear and detailed explanation of the manufacturing process flow, designed to be straightforward and easy to understand. It's intended as an orientation for new employees at Ford, so I'll keep it simple and focused. This version adds a touch of formality and clarity, perfect for an introductory presentation. Let me know if you'd like any more adjustments or if you're ready to move on to the dialogue practice.
Okay, I got it. I got it. I understood. Well noted. However, unless there are significant grammatical errors, you don't need to give me a refined version to improve my expression. Because as I told you before, one method most is how much time I've spent for speaking English in this practice session. So I want to speak as much as I can possible, and I will leave you. I mean, I will have listening time, one more listening time after our voice mode finished, because uh, I can do it because I'm recording our whole practice session, and I will upload it on YouTube platform.
Understood. Your focus is on maximizing speaking time and then reviewing your progress through the recording afterward. That's a great approach, getting the most practice in now and refining later. I'll keep my feedback minimal, focusing on any major errors only, so we can keep the conversation flowing smoothly. Let's jump into the next part whenever you're ready.
Okay. Uh, listen carefully. Listen carefully.
Perfect. Let's keep going. What's next?
Listen carefully. Listen carefully. Listen carefully. This today Uh, today's section, today's press section is not for a dialogue, conversation dialogue. Uh, this today's section is for just explanation section, explanation time. I would like to introduce, I would like to explain the manufacturing process flow for assembly line and assembly line. Listen carefully. Number one, material warehouse. Imagine that we are in the material house. This is the first process. Listen carefully. We start by receiving and storing all raw materials and components needed for production in the warehouse. These include PCBs, solder paste, and various electronic components. I say one more time. We start by receiving and storing all new materials and components needed for production in the warehouse. This includes PCBs, printed circuit boards, solder paste, and various electronic components.
Got it. I'm listening carefully. Here's what you shared. Today's session is for explanation, not for dialogue. I'll introduce the manufacturing process flow for the SMT line and assembly line. First step, the material warehouse. Imagine we're in the material warehouse. This is where we start by receiving and storing all raw materials and components needed for production. This includes PCBs, printed circuit boards, solder paste, and various electronic components. Your explanation is clear and effective. Just keep up the smooth flow as you go through each step in the process. Ready for the next part.
Okay, let's move on to the next part. Imagine that we are in the SMT line. At the first process of the SMT line. Let's move on to uh, the first stage of the SMT line. Listen carefully. Vacuum loader. The PCBs are loaded automatically from the warehouse to the production line using a vacuum loader, which helps in handling the boards without causing damage. Don't take it too seriously. This is just a simple sentence. And honestly speaking, our company couldn't automatically upload PCBs on the SMT line. I mean, uh, we have, I mean, our inline SMT line can load PCBs using a vacuum loader from the work table, but we couldn't automatically load it from the warehouse because workers have to move from the warehouse, have to move, workers have to move PCBs from the warehouse to SMT inline. Do you understand?
Got it? Here's the breakdown of what you shared. Now imagine we're at the SMT line, starting with the first stage, the vacuum loader. Here, PCBs are automatically loaded onto the production line using a vacuum loader, which handles the boards gently to avoid damage. However, in our company, we can't automatically load PCBs directly from the warehouse. Workers need to move the PCBs from the warehouse to the SMT line, and then the vacuum loader handles them from the work table onward. Your explanation is clear and detailed, and I appreciate the extra context about how your specific setup works. Just keep this natural flow going, ready for the next step when you are.
If you don't mind, please let me listen one more time. Would you mind saying that one more time, please?
Of course, here it is one more time. Now imagine we're at the SMT line, starting with the first stage, the vacuum loader. Here, PCBs are automatically loaded onto the production line using a vacuum loader, which handles the boards gently to avoid damage. However, in our company, we can't automatically load PCBs directly from the warehouse. Workers need to move the PCBs from the warehouse to the SMT line, and then the vacuum loader handles them from the work table onward. Let me know if you'd like me to repeat any part or go over the next stage.
Okay, let's move on to the next step. Well noted. Okay, I got it. Let's move on to the next step. Screen printer. Here, solder paste is applied to the PCB. Listen carefully. This is one of the most important process in the SMT line. Here, solder paste is applied to the PCB. The screen printer uses a stencil to ensure the solder paste is accurately placed on the areas where components will be mounted. Do you understand?
Yes, I understand. Here's what you explained. The next step is the screen printer. In this process, solder paste is applied to the PCB, which is one of the most important steps in the SMT line. A stencil is used to ensure that the solder paste is accurately placed on specific areas where the components will be mounted. Your explanation is clear and covers the purpose and importance of the screen printing process well. Ready for the next step when you are.
Have you ever heard metal mask? Usually, you used to, I mean, usually you used to call it metal mask instead of stencil. Do I make myself clear? Stencil means metal mask, and in our company, I mean, in most of Korea SMT company, usually use metal mask instead of stencil. Do I make myself clear?
Got it. Thanks for clarifying. So, in your company, and generally in most Korean SMT companies, you usually say metal mask instead of stencil. That makes sense. I'll remember to use metal mask from now on in this context. Thanks for making that clear.
Okay, let's move on to the next step. Let's move on to the next process. Chip mounter. Chip mounter process has two machines. Uh, Chip mounter and multi mounter. Chip mounter is for small components, and a multi mounter is a bigger component. Do you understand? In this step, small electronics small oh my god, apologies for my bad pronunciation. Let me try one more time. Small electronic components such as resistors and capacitors are mounted onto the PCB. The machine picks the components from the feeder and place them special preciously. I say one more time. Place them preciously on the solder paste coated pads. You understand?
Yes, I understand. Here's what you explained. The next step is the chip mounter, which involves two types of machines: the chip mounter for small components and the multi-mounter for larger components. In this process, small electronic components like resistors and capacitors are mounted onto the PCB. The machine picks the components from the feeder and places them precisely on the solder paste coated pads. Your description is clear and emphasizes the precision of the placement. I'm ready for the next step when you are.
Okay, let's move on to the next one. Let's move on to the next process. SPI, solder paste inspection. This is very important process, and we need to keep CPK. We need to maintain SPC process for this inspection system. There are specific there is specific requirement for this inspection process. We need to maintain over 1.67 CPK in this process for solder paste volume. Do you understand? After the components are mounted, we inspect the solder paste. We inspect the solder paste deposits using a 3D scanner. This ensures that the right amount of solder is applied and positioned correctly. Do you understand?
Yes, I understand. Here's your explanation. The next process is SPI, or solder paste inspection, which is a crucial step. For this inspection system, we need to follow strict SPC, Statistical Process Control Standards, and maintain a CPK, Process Capability Index, of over 1.67, specifically for the solder paste volume. After the components are mounted, a 3D scanner inspects the solder paste deposits. This ensures that the correct amount of solder is applied and positioned accurately. Your explanation clearly covers the importance of maintaining process control and the technical requirements. Ready for the next part when you are.
I'm sorry. I missed your comment. Please let me listen one more time. If you don't mind, please let me listen one more time.
Of course, here it is one more time. The next process is SPI, or solder paste inspection, which is a crucial step. For this inspection system, we need to follow strict SPC, Statistical Process Control Standards, and maintain a CPK, Process Capability Index, of over 1.67, specifically for the solder paste volume. After the components are mounted, a 3D scanner inspects the solder paste deposits. This ensures that the correct amount of solder is applied and positioned accurately. Let me know if you'd like me to repeat or clarify anything else.
Okay, I got it. I'm sure you understand correctly. Let's move on to the next one. Reflow oven. The PCB with the components placed goes through the reflow oven. Here, the heat melts the solder. Listen carefully. This is very important. Here, the heat melts the solder, forming permanent connections between the components and the PCB. You know, we have to maintain a specific heat profile, heat profile for this process because uh, for the reflow oven, maintaining heat profile is very important, really important to make sure every component, uh, every component formed permanent connection between the components and PCB. And you know, if we if we control if we control or maintain uh, proper heat profile, the outline of the solder outline of the soldering meets the specific specification. There is specific specification. Uh, there is specific customer specific requirement for the soldering quality. To understand.
Yes, I understand. Here's a recap of your explanation. The next process is the reflow oven. In this step, the PCB, with components already placed, goes through the reflow oven, where heat melts the solder to create permanent connections between the components and the PCB. Maintaining a specific heat profile is absolutely essential in this process to ensure reliable connections and meet the soldering quality standards. Proper heat control helps achieve the required soldering outline, which must meet customer-specific quality requirements. Your explanation emphasizes the importance of the heat profile in achieving durable solder joints that meet customer specifications. Let me know if you're ready to move on to the next step.
Let's move to the next step. AOI, automated optical inspection. AOI means automated. Let me try one more time. AOI means automated optical inspection. The board, the board is in then the board is in then inspected using camera to ensure that all components are correctly placed and soldered. This is an automated process to catch defects such as misalignment or missing components. Let me say one more time. This is an automated process to catch defects to catch defects. This is an automated process to catch defects such as misalignment or missing component.
Got it. Here's what you explained. The next step is AOI, or Automated Optical Inspection. In this step, a camera inspects the board to ensure all components are correctly placed and soldered. This automated process is designed to catch defects like misaligned or missing components. Your description clearly explains AOI's role in quality control. Ready for the next part when you are.
Okay, I'm ready. I think I'm ready. Let's move on to the next part. I think I'm ready. Next process is a router. The PCB is separated from the main panel. If multiple boards were processed together, a router machine cuts the board into the individual pieces. Okay, let me practice. Let me try one more time. The PCB is separated from the main panel. A router, a router machine cuts the board into the individual pieces. Do you understand?
Got it. Here's what you described. The next process is the router. In this step, the PCB is separated from the main panel. If multiple boards were processed together, a router machine cuts them into individual pieces. Your explanation is clear and concise, and you're expressing it well. Let me know when you're ready for the next step.
Okay, I got it. I got it. Let's move to the next step. Next step is X-ray inspection. Some boards undergo X-ray inspection to check hidden solder joints, hidden solder joints that cannot be inspected by AOI. Connections like connections on the large components, like connections on the BGA. Listen carefully. Uh, I'd like to I'd like to explain one more time. Listen carefully. Some boards uh, no, 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 no. This sometimes, usually we are doing X-ray inspection based on sample process. So some boards undergo X-ray inspection to check hidden solder joints that cannot be inspected by AOI. Connection on the BGA. You know, listen carefully. I have something to tell you. Mm, The purpose of X-ray, the purpose of X-ray inspection is to inspect uh, the hidden solder joint on the BGA chip, and sometimes to inspect uh, the soldering quality of selective soldering. Selective AUI machine can't inspect the soldering quality of selective process. So we have if some PCBs have selective soldering process, we have to inspect every board for selective soldering quality. To understand, if if some board if some if 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 mm, how can I express this? How can I express this situation better? If some boards have selective process, we have to inspect every of them, not the not the sampling base. To understand?
You're explaining it well. Here's a more refined way to express it. Next is the X ray inspection. Typically, this is done on a sample basis, where some boards undergo X ray inspection to check hidden solder joints, especially those on large components like the BGA chip that can't be inspected with AOI. The purpose of X-ray inspection is to ensure the quality of these hidden connections and, when selective soldering is used, to inspect those joints as well. Since AOI can't assess selective soldering quality, we need to inspect every board with selective soldering rather than just sampling. This keeps your explanation clear and focused on the purpose and necessity of X-ray inspection, especially with selective soldering processes. Let me know if you'd like to try anything differently or move to the next step.
I just want to listen one more time. If you don't mind, please let me listen one more time.
Of course, here it is one more time. Next is the X-ray inspection. Typically, this is done on a sample basis, where some boards undergo X-ray inspection to check hidden solder joints, especially those on large components like the BGA chip, that can't be inspected with AOI. The purpose of X-ray inspection is to ensure the quality of these hidden connections, and, when selective soldering is used, to inspect those joints as well. Since AOI can't assess selective soldering quality, we need to inspect every board with selective soldering, rather than just sampling. Let me know if you'd like any other adjustments or are ready to continue.
It depends. It depends. How we proceed with this process, it depends on the importance or the cost of the project. If we have very important and expensive board, we have to inspect every board. We have to go through X-ray inspection based on the whole inspection process. However, uh, if there is no BGA or selective soldering process, sometimes we take X-ray inspection based on a sampling process. Do I make myself clear?
Yes, you made yourself clear. Here's a refined version for clarity. How we proceed with X-ray inspection depends on the project's importance and cost. For very important or high-cost boards, we perform a full inspection on every board. However, if the board doesn't have BGA components or selective soldering, we may use a sampling process for X-ray inspection. Your explanation is clear and emphasizes the flexibility based on project needs. Let me know if you're ready to continue.
Okay, I got it. That's exactly what I want to say. Well noted. Okay, I will review and check after our voice mode session is finished. Okay, let's move to the next one. ICT, in-circuit test. We conduct electronical testing to ensure that the board works as expected. Let me try one more time. We conduct electrical testing. We conduct electrical testing to ensure that the board works as expected. This includes checking for short circuit, open circuit, and component functionality. Let me say one more time. Let me practice one more time. We conduct electrical testing to ensure that the board works as expected. This includes checking for the short circuit, open circuit, and component functionality. This is, I believe, this is one of the very important process in the HFT line.
Exactly, you explained it well. Here's what you said. In the ICT, or in-circuit test, we conduct electrical testing to make sure the board functions as expected. This includes checking for short circuits, open circuits, and component functionality. I believe this is one of the most important processes in the ICT lab. Your explanation is clear and highlights the essential checks in ICT. Let me know if you're ready for the next step.
I don't understand. You mentioned ICT lab. I don't know what for in the last line. I don't understand. What that mean? When you mentioned ICT lab.
Good question. When I mentioned ICT lab, I meant the place where in-circuit tests, ICT, are conducted. Some companies have a designated area or lab for performing ICT, where boards go through electrical testing to check for things like short circuits, open circuits, and functionality. If that doesn't apply to your situation, we could simply say, I believe this is one of the most important processes in ICT.
Yes, yes. For our company, ICT process is in the inline. So we have to inspect. We have to we have proceed with ICT process with every every board every I mean every board must undergo
Got it.
ICT process.
So, in your company, the ICT process is done in line, meaning every single board goes through ICT testing as part of the production line process. Here's a way to express that. In our company, ICT is an inline process, so we conduct ICT testing on every board to ensure each one meets quality standards. Let me know if that works for you.
Yes, that's exactly what I want to say. Every single. Oh, no, no, no.
Great. You're expressing everything really clearly. Let me know if you're ready to keep going.
I just want to say every single PCB, every single PCB assay must undergo ICT process because it's in inline process. We don't have any specific room for this for this inspection. ICT machine is in the middle of the assembly line. You understand?
Perfect. Here's a clear way to say it. Every single PCB must undergo the ICT process because it's an inline process. We don't have a specific room for this inspection. The ICT machine is located right in the middle of the assembly line. This version keeps your explanation direct and specific to your setup. Let me know if you'd like to practice anything else.
Okay, I got it. Well noted. Let's move to the next one. Next one, PCB cleaner. Listen carefully. Before proceeding, the PCB is cleaned to remove. Oh my God, oh my God. I'm sorry for my bad pronunciation. I think I'm still beginner for English pronunciation. Okay, listen carefully. Okay, let me try one more time. Let me challenge you one more time. Before proceeding, the PCB is cleaned to remove any leftover solder flux or conta- uh, conta- contaminants. Contaminants. Could you please share me the dictionary meaning of the word contaminant?
No problem at all. You're doing great, and your pronunciation is clear enough to understand. Here's the dictionary meaning of contaminants. Contaminants, substances that make something impure or dirty by contact or mixture. In manufacturing, contaminants can refer to unwanted substances like dust, solder flux, or other residues that could affect product quality. And here's your sentence again. Before proceeding, the PCB is cleaned to remove any leftover solder flux or contaminants. Let me know if that helps.
Let me try one more time. Before proceeding, the PCB is cleaned to remove any leftover solder flux, leftover solder flux, leftover solder flux, leftover solder flux, or contaminants. I messed up with the word leftover because I'm not familiar with this word leftover. So I messed up. I think I messed up with this word uh, when I want to pronunciate it clearly. So let me try one time. Before proceeding, the PCB is cleaned to remove any leftover solder flux or contaminant.
You did great. Leftover can be a tricky word to pronounce smoothly, but you're getting the hang of it. Here's the line again for practice. Before proceeding, the PCB is cleaned to remove any leftover solder flux or contaminants. And just to clarify, flux is the correct term here instead of plugs, which refers to the residue left from the soldering process. Let me know if you'd like to practice it once more.
Mm, I think uh, for now, I think it's enough. Let's move on to the next one. Laser marking. Unique serial numbers or QR codes are laser engraved onto the each PCB for traceability and identification. You know, I I I think I need to change the introduction script to switch the process because laser marking is the first process of SMT9. Listen carefully. Unique serial numbers or QR codes are laser engraved, laser engraved onto each PCB for traceability and identification. Traceability is traceability is one of the most important thing that have to show uh, our manufacturing history. Okay.
Got it. Here's a clear way to say it. Laser marking is actually one of the first steps in the SMT process. Unique serial numbers or QR codes are laser engraved onto
Yeah, yeah,
each PCB for traceability and
yeah,
identification.
맞습니다.
Traceability is one of the most important
Yeah,
aspects I
yeah.
emphasize to our manufacturing team. Your explanation sounds clear and highlights the importance of traceability. Well, let me know if that sounds good or if you'd like to make any adjustments.
I'm sorry, I'm sorry. I just communicate with someone. I mean, I just received a sudden call from my family. So, if you don't mind, please let me listen one more time. I'm sorry, I'm sorry. I missed it because I just received an important call from my family. So, if you don't mind, please let me listen one more time.
No problem at all. Take your time, and we'll pick up right where we left off whenever you're ready.
No, 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 no. If you don't mind, please let me listen one more time. What you told me a moment ago.
Of course, here it is. Laser marking is actually one of the first steps in the SMT process. Unique serial numbers or QR codes are laser engraved onto each PCB for traceability and identification. Traceability is one of the most important aspects I emphasize to our manufacturing team. Let me know if you'd like any changes or are ready to continue.
Okay, okay, okay. I'm sure I understand what you're trying to say. Okay, let's move on to the next one. Next process. NG buffer. Defective boards are sent to a designated buffer for review and repair. Good boards continue to the next step. Understand? Let me practice one more time for this process. Defective boards are sent to a designated buffer in the assembly line. It's automated process. NG buffer is automated process. Defective boards are sent to a designated buffer for review and repair. Good boards continue to the co- good boards continue to the next step. Good boards continue to the next step.
I understand. Here's a clear version of your explanation. The next process is the NG buffer. In this step, defective boards are automatically sent to a designated NG buffer for review and repair, while good boards continue to the next step in the line. Your explanation is clear, emphasizing that the NG buffer is an automated process to separate defective boards for inspection. Let me know if that sounds right or if you'd like to practice further.
Okay. Let's move on to the next one. Well noted. Well noted. Thank you for your kind support. I really appreciate your kind support and your patience for my repetitive and tedious content. Let's move on to the next one. Finally, it's for unloader process. Finally, the complete board are unloaded from the SMT line and transported to the assembly line for further processing. For our company, after unloader, there is specific area for the uh, for the storage. Do you understand? We need many trays or uh, shell for the PCBs after unload process.
You're very welcome. Here's a summary of what you explained. Finally, in the unloader process, the completed boards are unloaded from the SMT line and transported to the assembly line for further processing. In our company, after unloading, there's a designated storage area where we keep the PCBs. We need multiple trays to store the boards properly after they're unloaded. Your explanation is clear, and you added good details about your specific setup. Let me know if you'd like to go over anything else or if you're ready to wrap up.
Okay. Let's move to the next one. Manufacturing process. Next to manufacturing process. Step 2, assembly line. We talk about the SMT line first, and let's move on to the next one, assembly line. Number 1, active alignment. It's called AA process. Active align means AA process. Here, camera modules are aligned and assembled with precision to ensure uh, they function correctly in real-world conditions, such as focusing and image quality. Basically, this is most important process of whole uh, whole whole manufacturing process. Listen carefully. Here, camera modules are aligned. I mean, uh, sensors sensors and lens are aligned and assembled with precision to ensure they function correctly in real world conditions such as focusing and image quality.
Got it. Here's a refined version of your explanation. Moving on to the assembly line, starting with step 1, active alignment, also known as the AA process. In this step, camera modules, including the sensors and lens, are aligned and assembled with high precision to ensure they function correctly in real-world conditions, especially in terms of focusing and image quality. This is the most critical process in the entire manufacturing line. Your explanation highlights the importance of active alignment and the precision needed for camera performance. Let me know if you'd like any adjustments or if we're ready for the next step.
If you don't mind, please let me listen one more time. Please explain your uh, original comment one more time.
Of course, here's the original explanation again. Moving on to the assembly line, starting with step 1, active alignment, also known as the AA process. In this step, camera modules, including the sensors and lens, are aligned and assembled with high precision to ensure they function correctly in real-world conditions, especially in terms of focusing and image quality. This is the most critical process in the entire manufacturing line. Let me know if you need any more details.
Okay, let's keep moving. Oven cure. Some components require curing after assembly, especially adhesives used to secure parts. This is done in an oven. Listen carefully. Oven cure. Oven cure is simple but important process. Some components require curing. No. Not some components. Every every uh, every product. I mean, for this process, every product after AA process require curing assembly, require curing process, especially adhesives used to secure parts, especially adhesives used to secure parts. This is done in oven. You know, like I said, AA process needs specific adhesives to secure lens and sensor. In AA process, UV light, I mean UV, uh, uh, we you are AA machine curing the product after AA process using UV laser, UV light, UV technology to uh, to make secure slightly before oven cure process, and then in oven cure process, every product, I mean, as I told you before, every product needs oven cure process after a process, because in the in the uh, AA process, UV technology can hold can hold uh, can hold sensor and lens just for short time. It's not strong connection. If we need to connect it permanently, we need product need to go through oven cure process. To understand? How can I express this situation very well? Can you help me?
Yes, I hear you, and I understand what you're describing. Here's a refined way to express it. Oven curing is an essential process that every product goes through after the AA process. During active alignment, adhesives are applied to secure the lens and sensors, and UV light is used to set the adhesive temporarily. However, this initial UV cure only provides a short term hold. For a permanent bond, each product must go through the oven curing process. The heat in the oven fully cures the adhesive, ensuring a strong, lasting connection between the lens and sensors. This version clarifies the need for both UV and oven curing for a secure, permanent connection. Let me know if that sounds good or if you'd like to adjust any details.
Sounds pretty good. Sounds pretty good to me. If you don't mind, please let me listen one more time.
Of course, here it is with comments for clarity. Oven curing is an essential process that every product goes through after the AA process. This sentence emphasizes that all products, not just some, require oven curing after active alignment. During active alignment, adhesives are applied to secure the lens and sensors, and UV light is used to set the adhesive temporarily. Here, it clarifies that UV light is used in the AA process to temporarily hold the adhesive. However, this initial UV cure only provides a short-term hold. For a permanent bond, each product must go through the oven curing process. These sentences explain that the UV cure is temporary and the oven cure is necessary for a lasting bond. The heat in the oven fully cures the adhesive, ensuring a strong, lasting connection between the lens and sensors. This final sentence highlights the role of heat in creating a permanent connection. Let me know if this helps or if you'd like any more comments.
Well noted. I got it. Well noted. I think you explained it very effectively. I think I think you explained it very professionally. In this case, I think you are worker. I think you are I think you are more professional than me. I mean you explained it very well in English.
Thank you so much. I'm glad the explanation was clear and helpful. Your detailed descriptions make it easy for me to understand the process. So it's a team effort. Let's keep up the great work. Ready for the next step whenever you are.
Okay, let's move on to the next step. IR LED assembly. Listen carefully. So IR LEDs used for a night vision or low light condition are mounted onto the camera assembly. Listen carefully. I say one more time. I practice one more time. I practice one more time. The IR LEDs used for the night vision or low light condition are mounted onto the camera, mounted onto the, are mounted onto the, are mounted onto the, are mounted onto the camera assembly.
Got it, and you explained it well. Here's a recap. The IR LEDs, which are used for night vision or low light conditions, are mounted onto the camera assembly. Your repetition is making it clear and precise. Let me know if you're ready for the next step or would like any adjustments. Sorry, I'm having issues right now. Could not understand what you said.
I didn't mention anything. It's technical glitches you have. I didn't mention anything. Let's move on to the next one. Thermal glaze, rear body. Thermal glaze. Thermal glaze is applied to the rear body to improve heat dis dissipation. Dissipation. Heat dissipation. Heat dissipation. How about my pronunciation for heat dissipation? Okay. Ensuring the camera doesn't overheat during operation. Ensuring the camera doesn't overheat during operation. Ensuring the camera doesn't overheat during operation. I practice one more time. Thermal glaze is applied to the rear body to improve heat dissipation, ensuring the camera doesn't overheat during operation.
Your pronunciation of heat dissipation sounds good. Here's a smooth version based on what you explained. Thermal grease is applied to the rear body to improve heat dissipation, ensuring the camera doesn't overheat during operation. Your repetition is working well to make it clear and precise. Let me know if you're ready for the next step or need any more feedback on pronunciation.
We don't have time. We don't have time. We have to hurry and move on to the next one. Rear body assembly. The rear housing of the camera is assembled, protecting the internal components. The rear body housing of the camera, rear body housing of the camera is assembled, protecting the internal components. To protecting the internal components.
Got it. Here's a clear version of what you shared. The rear body of the camera is assembled, protecting the internal components. Your repetition is helping reinforce it, and it sounds great. Ready for the next step whenever you are.
So you mean I have to remove two in the middle of context? in front of the protecting, I have to remove two. Am I right? What's your? Oh my God! Oh my God! Terrible! Oh my God! Are you okay? Are you with me?
Yes, I'm here with you. It sounds like you're practicing how to close a session or invite people to reach out. Here's a refined version of your message. Thank you for watching. If you have any questions, please feel free to contact me. I'm available in the chat for Omika. Are you with me? This keeps it clear and professional. Let me know if you'd like to adjust any part of it.
Listen carefully. How about my last line? Can you remember my last line? People you just left our conversation process. So I'm wondering, can you can you access my last line? Listen carefully. My last line is the rear housing of the camera is assembled, protecting the internal components. How about uh, my, I'm using the two in this context. The rear body housing of the camera is assembled to protecting the internal components. Which one is right? Which one do you prefer?
I'm with you, and I remember your last line. In this context, the correct phrasing would be the rear body housing of the camera is assembled to protect the internal components. Using to protect instead of to protecting is correct because it follows the structure of assembled, so assembled to protect is the right choice. Your original line, the rear body housing of the camera is assembled, protecting the internal components, also works well and sounds natural.
Now I understand. Okay, I understand very well. Well noted. I really appreciate your kind comment. Okay, let's move on to the next one. Next step. Camera cover assembly. Cover assembly. The camera lens cover or protect cover is attached to the assembly to protect the lens from damage and contaminants. Listen carefully. I practice one more time. The camera lens cover or protective cover is attached, attached to the assembly to protect the lens from the damage or contamination.
That's perfect. Here's your sentence again, just as you said it. The camera lens cover, or protective cover, is attached to the assembly to protect the lens from damage and contaminants. Your explanation is clear, and your pronunciation is on point, ready to move on whenever you are.
Okay. Let's move on to the next one. Shading. Let's move on to the next step. Shading. This process involves applying coating or materials to prevent light leakage or underwater reflection inside the camera module. Listen carefully. Listen carefully. Honestly speaking, I'm not sure what a shading process means. What's the shading process? What's the purpose of shading process? But listen carefully. I just want to read the to keep these useful words and sentences in my mouth and my mind. As I told before, I'm not sure what is the main purpose of trading process, but just listen carefully. I just want to practice this line to keep to keep them in my mind and my mouth muscle. This line contains very useful and powerful words for my real life situation. So listen carefully. This process involves applying coatings or materials to prevent light leakage or unwanted reflections inside the camera module. Listen carefully. I say one time. This process involves applying coatings or materials to prevent light leakage or unwanted reflections inside the camera module.
You're doing an excellent job practicing. Here's the line as you explained it. This process involves applying coating or materials to prevent light leakage or unwanted reflections inside the camera module. Your repetition and focus on useful words are really effective for keeping these phrases in mind and improving your fluency. Even if you're not fully familiar with the shading process, practicing like this will help you remember the technical terms. Let me know if you're ready to move on.
Okay, let's move on to the next one. IPC. Let's move to the next step. IPC. In process check. IPC. Honestly speaking, IPC not means in process check. My original note was wrong. It's not correct. IPC means uh, in, intrinsic parameter calibrate. Intrinsic parameter. I say on time. Intrinsic parameter calibration. It means intrinsic parameter calibration, not the in-process check. Do I make myself clear? In this step, we perform checks to ensure that all assemblies meet the quality standards at various stages of production. Uh, you know, this step is based on the software calibration. So IPC process is very difficult process for many workers because it's very uh, it's very technological to the software. I mean, this process uh, based this process based on the software calibration technology. So many workers, including me, don't understand the main mechanism, root mechanism of process to understand.
Yes, you made yourself clear. Here's a refined version to summarize. IPC stands for Intrinsic Parameter Calibration, not in process check as I originally thought. In this step, we perform checks to ensure that all assemblies meet quality standards at various stages of production. This process relies heavily on software calibration technology, which makes it quite complex for many workers, including myself, to fully understand the underlying mechanisms. Your explanation highlights both the purpose of IPC and its technical complexity due to software calibration. Let me know if this captures it well or if you'd like any adjustments.
I think you understand very well. I'm sure you understand you understand based on you understood very well. You understand this process very well based on my poor explanation. Okay, thank you, and I appreciate your kind understanding. Okay, let's move on to the next step. Next step is for EOL, end of line testing. EOL, EOL. At the end of the assembly line, the camera undergoes final inspection test to ensure it worked correctly. This includes image testing and other many performance checks. At the end of the assembly line, the camera undergoes final functional test to ensure it works correctly based on the customer requirement. This includes image testing and other 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 many performance checks.
Thank you. Here's a clear version of your explanation. Next is EOL, or end of line testing. At the end of the assembly line, the camera undergoes a final functional test to ensure it meets customer requirements and works correctly. This includes image testing and many other performance checks. Your explanation is spot on and covers the purpose and focus of EOL testing clearly. Let me know if you're ready for the next step.
Okay, let's move. We don't have time. Let's hurry and move on to the next step. Visual inspection. Visual inspection. Trained inspectors. Trained inspector. It's very important. Trained inspectors. Trained inspectors visually check the final product. Uh, I say okay. Oh my god. Oh my god. I messed up. Oh my god. Let me try one time. Trained inspectors visually check the final product to ensure there are no cosmetic defects or assembly errors. Trained inspectors visually check the final product to ensure there are no cosmetic defects or assembly errors.
You got it. Here's your explanation, just as you said it. Trained inspectors visually check the final products to ensure there are no cosmetic defects or assembly errors. Your focus on trained inspectors is clear and emphasizes the importance of this step in the inspection process. You're doing great, ready for the next step whenever you are.
Okay, let's move to the next one. OQC, ongoing quality control. Ongoing quality control. Before shipping the product, before shipping the product to customers, before shipping the before shipping the product to customers, before shipping the product to customers, we perform a final quality checks to ensure that it it meets all necessary specifications and standards. Listen carefully. As a quality manager, I need to focus on I want to focus on the last process because I'm in charge of quality department. So, as I told you before, I am a quality manager. So I want to just focus on the last process. I mean, OQC process, or outgoing quality control. Before shipping the product to customers, we perform a final quality check to ensure that it meets all necessary specifications and standards.
Perfectly explained. Here's your statement OQC, or outgoing quality control. Before shipping the product to customers, we perform a final quality check to ensure it meets all necessary specifications and standards. As the quality manager, I focus on this final process to ensure everything is up to standard. You've clearly highlighted the importance of OQC and your role in it. Let me know if you're ready to wrap up or continue with anything else.
I think we need to wrap up the major two assembly process, assembly line and assembly line. Listen carefully. This is a simplified explanation of SMT and assembly process flows. Each step is designed to ensure that the products meet the highest quality standard, meet the highest quality standard. So feel free to ask if you need, feel free to ask if you need more details on any part of the process.
Great wrap up. Here's your closing summary. This is a simplified explanation of the SMT and assembly process flows. Each step is designed to ensure that the products meet the highest quality standards. Please feel free to ask if you need more details on any part of the process. Your summary is clear and professional, leaving the door open for questions. Nicely done.
Okay, how about this one? Let's dive into detailed explanation of the process. Listen carefully. Here's an explanation of SPI, solder paste inspection process in assembly line in English. Listen carefully. Solder paste inspection, SPI, is a crucial process in surface mount technology production. It occurs after it occurred after solder paste has been applied to the PCB using a metal mask. Using a metal mask. Using a metal mask. The the main purpose of SPI is to inspect the quality and accuracy of the solder paste deposition before components are placed on the board. Mm, during the pro during the process during the
That
process.
sounds excellent. Here's your explanation with a slight refinement for smoothness. Let's dive into a detailed explanation of the SPI, or solder paste inspection process. SPI is a crucial step in surface mount technology production. It takes place after solder paste has been applied to the PCB using a metal mask. The main purpose of SPI is to inspect the quality and accuracy of the solder paste's position before components are placed on the board. Your explanation is clear and effectively covers the purpose and timing of SPI in the process. Great job.
Okay, however, don't interrupt my speaking anymore. Listen carefully. I was talking. I was talking. Talking about the SPI process. Listen carefully. During the SPI process, a 3D inspection system scans the solder paste deposits on each pad to check for various defects on such volume consistency, ensuring that the correct amount of solder paste is deposit, deposited on each pad. Too little solder can lead to weak connection, while too much can cause breaching between pins. Okay, shape. Checking if the shape of the solder paste is correct. Incorrect shape can lead problems during equal soldering. Alignment. Verifying that the solder paste is aligned properly with the pad on the PCB. Height. Ensuring that the thickness or height of the solder paste is, is within the required specification. By identifying defects at this early stage, the SPI process helps to reduce the risk of soldering issues that can occur after the SMT process, such as component misalignment or solder joint defects. This ultimately improves the overall yield and reliability of the electronic assembly. Do you understand?
Understood, and I'm listening carefully. Your explanation of the SPI process is detailed and covers all critical aspects like volume consistency, shape, alignment, and height. You clearly highlighted how each of these checks helps prevent soldering issues later on, improving yield and reliability. Great work.
Okay, let's keep going. Let's keep going. Let's hurry. We don't have time. Let's hurry. Here's an explanation of SMT mount process in English. Mount process, pick and place. Mount process means pick and place process. So SMT mount process, also known as the pick and place process, is one of the key steps in surface mount technology. This process involves placing the electronic components onto a printed circuit board that has already been coated with solder paste. Here's how the process works. Component feeder setup. Component feeder setup. SMT components such as resistors, capacitors, ICs, and transistors are typically stored in reels or trays in the machine's feeder. These feeders supply the components in an organized and automated manner to the pick-and-place machine. Number two, component pickup. The pick-up and place machine is equipped with high-speed robotic arms and a nozzle that pick up the components from the feeder. The machine's vision system identifies the exact location and orientation of each component for accurate placement. Number three, component placement. The machine places each component preciously onto the PCB where the solder paste has already been applied. This requires high precision to ensure that each component aligns correctly with the pad on the PCB. The solder paste helps temporarily hold the components in place before they go through the reflow soldering process. Inspection and adjustment. Some pick-up and place machines are equipped with vision systems that verify the placement accuracy during the process. This ensures that components are positioned. This ensures that components are positioned correctly in terms of alignment and orientation. If a component is misplaced, if a component if a component is misplaced, the machinery may the machine the machine may adjust it or notify the operator to correct it. Let me try one more time for the last line. Listen carefully. This ensures that components are positioned correctly in terms of alignment and orientation. If a component is misplaced, the machine may adjust or notify operators to correct it.
I'm listening carefully, and your explanation of the SMT mount pick and place process is very clear and well structured. You described each step from component feeder setup, pickup, and placement to inspection and adjustment, emphasizing the importance of precision in positioning components on the PCB. The repetition at the end was also helpful for reinforcing the key points on alignment and orientation. Great job keeping it detailed and focused. Sorry, I'm having issues right now. Could not understand what you said.
Thank you for your kind comment for my long explanation. Okay, let's move. We don't have time. Let's move on to the next step. Here's an explanation of reflow soldering process in SMT9. Reflow soldering is one of the most critical process in SM surface mount technology production. After the components are placed onto the PCB with the solder paste applied during the pick up and place process, the assembled board goes through the reflow soldering process to permanently attach the components to the board. The reflow process takes place in a specialized oven. I say one more time. The reflow process takes place in a specialized oven that uses controlled heat to melt the solder paste and form solid, reliable solder joints. This process typically involves several stages. Preheating. The temperature inside the oven is gradually increased to avoid thermal shock. During this stage, during this phase, the entire PCB brought to a uniform temperature. This helps in activating the plug within the solder paste, which cleans the metal surfaces to ensure good soldering. Number two, soak. In this case, the temperature is held at a level that allows the plug to fully activate and ensure that any volatile and ensure that any volatiles in solder paste vaporate. Vaporate. This helps stabilize the board temperature before entering the reflow phase. Number three, reflow. This is the main phase. Main phase. This is the main phase where the temperature is increased above the melting point of the solder. The solder paste melts uh, usually around 230 degrees Celsius degree to 250 Celsius degree. The solder paste melts, creating strong electrical and mechanical connection between the components and the PCB. Cure, cure must be taken to avoid overheating. Cure, no, bad, I'm sorry for my bad pronunciation. Care must be taken to avoid overheating, which can damage components or cause solder defects. Number four, cooling. After the reflow phase, the PCB is cooled down gradually to solidify the solder joints. Controlled cooling helps prevent thermal shock and ensure the shoulder pace ensures the shoulder solidifies ensure the shoulder solidifies correctly without creating defects like cracks or voids. Cracks or voids. The entire reflow process is closely monitored and controlled to ensure uniform heating and proper shoulder joint formation. It's crucial in the SMT process because any issues during after reflow can lead to shoulder joint failure, resulting in poor electrical components or component damage. Do you understand? How about what do you say about my long, detailed explanation?
I completely understand, and your detailed explanation of the reflow soldering process was excellent. You provided a clear breakdown of each stage: preheating, soak, reflow, and cooling, highlighting their importance and the specific conditions needed, like temperature control, to create strong solder joints. Your emphasis on avoiding thermal shock, preventing overheating, and ensuring proper cooling demonstrates your thorough understanding of each phase's purpose in achieving reliable connections. Your detailed and organized approach really brings out the critical aspects of reflow soldering. Well done.
Thank you for your kind comment for my long and detailed explanation. You know, uh, honestly speaking, this long, detailed explanation is from you. When I asked the explanation for our SM scribe, you suggest this explanation to me few weeks ago. Okay, anyway, anyway, uh, let me try. We have, I think we have just 5 minutes. So how about try my repetition time that I prepared yesterday? Listen carefully. From now on, I would like to share many short. Uh, I would like to share short sentences that are not related to each other. It's for my uh, mouth muscle training. I want to keep them in my mouth muscle. Listen carefully. It's great to hear how much you value this inspection interaction. Listen carefully. The first example is it's great to hear how much you value this interaction. It's great to hear how much you value oh my God, oh my God. It's great to hear how much you value this interaction. It's great to hear how much you value this interaction.
I'm listening carefully, and I can see you're doing a fantastic job with repetition for mouth muscle training. Here's your sentence once more for reinforcement. It's great to hear how much you value this interaction. Your dedication to practicing even small phrases will definitely help build fluency and natural rhythm in your speech. Keep going. You're doing excellent work.
It's great to hear how much you value this time.
Absolutely. Here's that sentence for more practice. It's great to hear how much you value this time. Your practice is spot on. Let me know if you'd like to keep going with more sentences.
How about this version? It's great to hear that how much you value this practice time.
Almost perfect. Just a small adjustment for smoothness. It's great to hear how much you value the practice time. Removing that in this sentence makes it sound more natural. You're doing great.
Okay, okay, I got it. I got it. It's great to hear how much you value this practice time.
Exactly. That sounds perfect. It's great to hear how much you value this practice. Your phrasing is natural and clear. Keep it up.
Okay, let's move to the next one. He called out the errors in the report. He called out the errors in the report. He called out. I mean, you called out the my you called out my mistakes in my speaking.
Perfect. Here's a way to connect it to your practice. He called out the errors in the report. Or if you want to make it more personal, you called out the mistakes in my speaking. Both are correct and sound natural. Great job with the phrasing.
I'm sorry. I'm sorry. Thank you for your kind support. We don't have time. I have to go. I have to work. I really want to keep our conversation time longer than this one, but I don't have time. Bye for now. Today is Friday. Thanks God. It's Friday. TGI Friday. Take care of yourself. Bye for now. I'm really looking forward to next break session. Take care. And when we say goodbye, you say 팽바. 팽바. 팽바.
No problem at all. Thank you for the great session. Penbai, take care, enjoy your Friday, and I'm looking forward to our next conversation. TGI
You too. Enjoy your Friday. 팽바. 팽바.